Couple definitions that we're going to take a look at to start off on this video. A median of a triangle is a segment that goes from a vertex to the midpoint of the opposite side. So real quick, let's jump down here to example 1 and let's look at where the medians, what would the three medians of this triangle would look like. So I got to start at a vertex. So I'm going to start with the first median. I'm going to start it at A, and then I go to the midpoint of the opposite side. So where does it look like the midpoint of that side would be? We're not going to get a ruler out and measure it. We're just going to kind of guesstimate. It looks like the midpoint would be right about here. That looks like the point that's going to divide this into two congruent parts. So let's go ahead and label that point D. Now I'm going to draw a segment that goes from point A down to that midpoint, point D. So there you have it. That's one median of this triangle. Now, what about the other medians? Well, we need to find the other midpoints. So the midpoint of segment AC looks to be maybe about right there. We'll call it point E. And then the midpoint of segment AB looks to be maybe right about there. We'll call that point F. Now we'll connect each vertex to the midpoint on the opposite side. So connect C to F. And then, oops, I did that in the wrong color. I want to connect B to E in orange. And then I want to connect C to F in my blue. So that would be the three medians of a triangle. Now you'll notice something interesting about that. All those medians, they intersected at that same point. That's kind of cool. That point is actually called the centroid of that triangle. And one of the interesting things about the centroid of any triangle is it's going to be the center of mass. If that was an actual physical triangle that we were holding in our hand, that would be the center of mass, which would indicate that actually this triangle, if we made it out of metal or cardboard or wood or styrofoam or something like that, we would be able to balance that triangle on that point right there. We could put a pencil right on that point, and we'd be able to balance that triangle on that center of mass. Just a little bit of trivia for you there. You don't need to know that. Now the other definition that we're going to look at is called the altitude of a triangle. The altitude of a triangle is the perpendicular segment that goes from a vertex to the line that contains the opposite side. So let's look at what those look like in example 2 right here. We're going to draw the three altitudes of this triangle. So to start with, we're going to go from B over here to segment AC, but we're not going to go to the midpoint anymore. We're going to go to a point where it's going to be perpendicular. So that looks to me like it's going to be maybe right about there. Now I'm going to indicate that it's perpendicular at that point with my little 90-degree angle box, just in case I got it slightly wrong. We're indicating that that's where we're trying to go. We're trying to make it perpendicular to AC. Now I'm going to do it again, going from A over here to BC. Again, I'm not going to the middle. I'm going to a place where it's going to make a 90-degree angle, which appears to be right about there. I didn't quite make it to the actual opposite side. So let me try that again. Looks like we're going right about there. Now let me mark that as a 90-degree angle. And lastly, I'm going to do the altitude that goes from C over to segment AB. So I'm going over here, whoops, I didn't get my line tool out, going over here from C to AB and making what looks like a 90-degree angle right about there. And there you have it. Those are the three altitudes. You'll notice they also intersect at the same point. So those are the three altitudes of a triangle, going from a vertex to a place on the opposite side where it's going to be perpendicular. Now, a couple different things you got to remember about altitudes. In a right triangle, all right, so let's look at a right triangle. Something kind of weird happens with the altitudes of a right triangle. So let me sketch out a right triangle. I got a side here. I want to make another side that's perpendicular to that, and then bring over my third side, the hypotenuse of my right triangle. Now this is a right triangle. So I have a 90-degree angle there. Let's call the vertices R, S, and T. The altitude that goes from R over to this side. Well, where is the altitude going from R over to this side? Right? If I wanted to go from R over to a side that contains, or a line that contains the opposite side, I'm just going straight down to T, aren't I? Right? That is perpendicular to the opposite side. And if I'm doing the same thing from S, if I'm going from S over to somewhere perpendicular to RT over here, I'm just going right down to T. So what that means is that in a right triangle, two of the altitudes will actually be sides of the triangle. And then the third altitude, right, our third altitude going from T, will be somewhere inside that triangle. It would be something like that, where the altitude lives kind of inside the actual triangle itself. But two of the altitudes are sides of the triangle. Now, in an obtuse triangle, so let's draw an obtuse triangle here. We're looking at obtuse triangles. So let's draw one of those real quick. I'm going to make an obtuse angle, right? Because that's what makes an obtuse triangle. It has an obtuse angle. So there we have what looks to be an obtuse triangle. Two of the altitudes are actually going to end up being outside the triangle, right? In this acute triangle up here, all of our altitudes were inside the triangle. In our right triangle, one of the altitudes was inside the triangle. But look what happens here with our obtuse. Let's call this triangle XYZ. Now, if I'm going to make the altitude that goes from Z to the opposite side, it might look something like this. It's going to be inside that triangle, no problem there. There's my altitude from Z in orange. But if I make the altitude from X, I can't go, oops, got my line tool out, I can't go from X anywhere over here on the actual side of the triangle and get it to be perpendicular. What I have to do first is I have to extend this side a little bit. So I'm going to extend this side further out, and then I can come down from X to that extended side, and I can find a place on that extended side where I can make a 90-degree angle. So you can see that altitude from X down to this point right here, if we wanted to give this a name, maybe we'd call that point Q. From X down to Q, that's my altitude, but it's not inside my original triangle XYZ. And if I was doing the altitude from Y, I'm going to see the same thing happen. Hopefully I have enough room on my screen to show that. I keep forgetting to get my line tool out. I make those squiggly lines. So if I extend this side right here down there, you can see that, well, I'm not going to be able to show it on the screen, but it would be somewhere like that, right? I'm a little bit off my screen, but somewhere down here would be where that place where the altitude from Y is going to go. So it's going to be outside the triangle. So that's just something quirky that happens with obtuse triangles and with right triangles. I'll let you guys try this on your own. You're going to draw the medians of this right triangle and draw the altitudes of this obtuse triangle. Let you guys do that on your own.